Hey, Akash. Oh, Akash, I couldn't hear you, actually. Let me bring out the chat window.
How about now? Can you hear me?
Yep, I can hear you now.
Okay, great.
So, Luis is out today, is that right?
Yeah, I think he probably won't join today. And then Binbin is, I don't think he'll join either.
Yep. We'll wait for a couple of minutes and see how many people we have today. Hope Jimmy would join. Let me check Slack. Do you see any messages from him today?
I don't think so. Yeah, I don't see anything specifically.
Okay, so cool. We'll wait for a couple of minutes. Give me time to adjust my screen.
If not, we can still discuss. I think this is the second time we've rescheduled for the metric stuff. So I think we can just discuss and then people can watch the recording later on.
Yep, sounds good. I have it on the agenda today.
Okay, cool.
Yeah, we'll probably start maybe like 1:05 if
Sure.
yeah, give people a couple of minutes. Is there any like cons or thing that's going on today?
Actually, that's a great point. When is KubeCon? That's next week, right?
Yeah, I checked the calendar. I didn't see any oof like for a conference or anything messages. But I'm wondering like why is it so quiet?
Yeah, I don't know. Maybe it's just one of those weeks.
Yeah. Is it spring break? No, that's coming up in 2 weeks.
Actually, that's a good point. Some schools do have spring break
Yeah.
week, so maybe kids are off.
Yeah, it is spring. The sakura's all like blooming and I think we're getting rain again for the weekend, but then it'll be sunny again next week.
Yeah, looking forward to this. I know last summer things started off a little late. The rain was all the way through June, so hopefully
Oh my God. Yes,
spring comes early.
yeah. Here's Sajay.
Okay.
Hello, Sajay. It's pretty quiet today. We're thinking we'll get started in 1 minute.
We can get some work done. We can even end the call early if folks want.
Yeah, we're actually, we can walk through the 3 items we have. The first one, Jimmy's PR on the AWS provider for region endpoints. Akash, I see you've commented. So there's some comments and there's a action item for Jimmy to resolve the conflict. Is there anything major that needs to be addressed?
Yeah, I'm not actually sure what state the PR is from his end. There's quite a bit of like commented sections of code that seems to have been used during testing. So I'm not sure if it's actually a work in progress PR or he may have missed some of those things. So just we'd have to follow up with him on that.
Yeah, and we're planning to release next Friday, right? So we hope to get this PR in
Yeah, I
hopefully
think
early next week.
yeah, that'd be very, if we can get it in, and then hopefully Jimmy can kind of sign off that things are working on the AWS side. So
Yeah, sounds good. And Akash is going to run through the metric proposal for Ratify today. It's been delayed for a couple of weeks now, so even with the small crowd, we should go ahead and review that.
You want to do this? I'm guessing you at least want Bin and all right on the call.
yeah, I'm okay waiting. My only concern was that it's kind of like blocking progress on it. So
Okay, good. Let's go for it.
okay.
I have
Okay.
enough history with metrics in my life. I think I can add some value.
Sounds good.
Akash, would you like to be the host to present?
Sure, yeah.
Yeah.
Okay,
Go ahead.
sure, just sharing my screen. Okay, can you see my screen?
Yes.
Okay, so I'm not going to go through this whole document because I think the more important discussion is like on the actual metrics that we want to discuss and might want to add or subtract from. But this document explains the different libraries and different metrics ingester providers that Ratify should support, and explains like what each of those does and their role in the Kubernetes scenario. So if people are more interested in that, can take a look at that. But I'll give a quick rundown of how I envision metrics support working in Ratify. It's pretty standard. A lot of Kubernetes projects use the same flow to a certain extent. So this is not a brand new thing for Ratify. But basically, starting off, we didn't have any metrics, of course, for Ratify, and this was posing problems when we were trying to understand what are the different components involved when you set up Ratify, especially when you're dealing with remote registries, you're dealing with key management systems like Azure Key Vault, you're dealing with a lot of identity network operations. So first and foremost, getting ideas on the number of requests going to each of these resources, the number of requests going to Ratify for verification, and then the latencies for all of these operations so that we can really get a sense of what might be a performance bottleneck, or or if Ratify is getting overloaded, what that looks like. So going off of that, there are two major components that we have to add to basically support the metrics workflow. The first is at the Ratify code base level, we need to interact with some sort of vendor agnostic instrumentation library, which will be responsible for actually reporting the metrics, exporting them to whatever metrics ingester that you have set up on the cluster. Or if you're not using Kubernetes and using a standalone Ratify server instance, you could also use the same metrics workflow to export to some other data source. So the obvious choice for this is OpenTelemetry. OpenTelemetry provides very expandable metrics and tracing support. And for this effort, we're not going to focus on tracing, but if we use OpenTelemetry, we can hopefully integrate tracing a lot easier in the future. And during the exploration part of this metrics support, I looked at some other projects for inspiration, so OPA Gatekeeper, and then some of the CSI secret store driver projects. And they also use a variant of OpenTelemetry. They use something called OpenCensus, which is the older version of OpenTelemetry. So OpenTelemetry was a merger between a couple projects, and now moving forward, they recommend that all usage is under the OpenTelemetry umbrella. So those existing projects are going to have to migrate. So rather than modeling our design exactly based off of theirs, we should just start with OpenTelemetry. So now that we have OpenTelemetry as a library we're going to use to actually collect the metrics and export them to a data source, we also need to provide support for a bunch of data providers which those metrics will flow to. The natural choice here in the Kubernetes setting is Prometheus, and implementation-wise, we'll make the provider infrastructure for metrics generic enough so that in the future, if someone wants to use something other than Prometheus, for example, in the tracing world, there's quite a few different options for tracing libraries apart from Prometheus. So using that provider ecosystem, we could expand on that in the future.
What are some examples of tracing libraries besides Prometheus?
So I'm not super familiar with them. I just know names. So Jaeger is one. I don't know exactly what the benefits are there.
Okay.
I know Grafana has their own tracing implementation too. And there are lots of other like cloud-specific tracing libraries apparently too. So OpenTelemetry supports something called the OTLP protocol, which is just like a data formatting protocol, and any sort of library that supports that can ingest metrics and more importantly tracing from that. So a lot of different cloud-specific libraries do that. For example, Google has something called Stackdriver, and that works too with OTLP.
Okay.
So yeah.
Quick question. Is the setup similar to how somebody would instrument Gatekeeper?
Yes, yeah. So from a Ratify perspective, we will expose the metrics using OpenTelemetry at a certain endpoint. So if we're using Prometheus, we'll have a Prometheus endpoint that exposes all the metrics at, and then it's up to the user to actually install Prometheus on the cluster and configure it correctly so that you're actually scraping the metrics from that endpoint. But that's not Ratify's domain to manage that installation experience.
Okay, makes sense. Well, what I'm trying to get to is, let's say somebody reads Gatekeeper's document of how to set up telemetry for Gatekeeper, and they come to Ratify. That knowledge that they've gained there should probably be transferable to, okay, we have done all this for Gatekeeper. It's just, I can use the same or similar steps just to kind of light up Ratify would be what I think would be a good experience, right? And it sounds like that, right, till now.
Yeah, no, that's a good point. I'll take a look exactly what their guide shows, and we can try to model our guide to be very similar to that. So it's just a very easy extension. But the work I've done in the initial PR, I've set up some end-to-end guides so that if you don't have Prometheus set up on your cluster, this is how we'd recommend it and what configs you're going to need to set up. So it kind of works seamlessly with Ratify and then the Grafana dashboard that Ratify can provide too. But that is all up to the user to just go through the guide and figure out if it works for them.
Makes sense. The reason why I feel that's important to kind of align with the Gatekeeper guide is because how many people are super passionate about learning setup, right?
Yeah, that's fair. Yeah. Sounds good. So I'll take a closer look to see how we can just make that whole process easier. Okay. So any questions about the flow of it? Does it kind of make sense so far? Okay, cool. So I'm not going to go in depth on how OpenTelemetry works here because the implementation wise, I think that is fairly standard. There's a few items that are helpful to know. So the main part is what instruments does OpenTelemetry support for metrics emission. So there's 3 types of metrics that they support. They support a counter metric, which is just a value that accumulates over time. So request count, number of signatures verified. And then using that, you can bin based off of time and figure out what the rate per second, per minute, whatever your interval is to see that. There's also a concept of a gauge. Gauge is a exact point in time values that's continuous data stream. In Ratify's case, we shouldn't really need this data source. This would be useful for things like if we wanted to tell what is the current size of the file system, if we wanted to emit what's the current size of the OCI store, for example, in the Aura store implementation, that might be more of a gauge metric. And then the third one is a histogram, and a histogram is kind of a counter metric wrapped up in a binned implementation. So you aggregate the number of occurrences based off of the bin boundaries that you've gotten. I think everybody's familiar with histogram. So yeah, and if you're curious, I've linked more information on the actual OpenTelemetry explanation of each of these metrics up here. Okay, so now that we have the metrics and the different metric types, we can go into a little bit more on Prometheus. So Prometheus is going to be the first data exporter that we support. And Prometheus is a pull-based system. So you set up a endpoint, and then you point Prometheus to that endpoint, and then Prometheus at a given scrape interval will scrape the metrics from that endpoint. And then from there, you can integrate with many of their other monitoring and dashboard solutions that they have. One of those is Grafana, which is the most popular one that I've noticed in this area. And we'll go into more of that later. But basically, in order to set up Prometheus, there are two parts. So the first part is, how do you actually tell Prometheus that where is this metrics endpoint set up? So for Ratify's case, we're going to spin up a separate HTTP server alongside the current Ratify server. And we want Prometheus to look at the pod, the Ratify pod, and say, hey, there's going to be a metrics endpoint on this particular pod. And then we want to scrape the metrics from this particular port as well. So the way you do that is by specifying an annotation on the pod spec. These two things are what tell the Prometheus controller that, okay, this is a resource that we want to start scraping. And then the second part of it is actually configuring Prometheus to scrape a particular resource type. So by default, the Prometheus community Helm charts ship with a very robust configuration that contains like multiple common resources that you'd scrape. For example, if you want to get pod memory metrics, things like that, you would have a configuration that is set by default in Prometheus that defines what those resources look like. What I've noticed is that for our case, we actually want to be scraping at the pod level for the Ratify pod level metrics. So you need to add one extra configuration in the form of applying a new config map. And then Prometheus will pick up the config map that you've added and add it to the list of configurations it's defined. So those are the two parts that you have to do in order to get this to work with the Ratify metrics endpoint.
Just a quick question, Akash. Like, if they already have a Prometheus server running just for it to report a different metric for a different pod, do they set the Ratify in a different port, or how do they have to do any different thing differently?
No, so the actual in-cluster IP will be different. So it actually, the Prometheus will pick it up as two different scrape targets.
Okay.
Yeah.
Yeah. Thanks.
Yeah.
So we'll have a different one to Gatekeeper.
Gatekeeper has a different one. Yes.
Got it. Thanks.
Yeah. And in our guide that we explain on how to install it, I've provided a guide where if you hadn't installed Prometheus at all, this is how you could do it. But I've also pointed out that in Ratify specific case, if you're adding on and you want to get Ratify to work with your existing Prometheus instance in the cluster, here's the config that we recommend you add. And the Helm chart itself is wired up so that the annotations, so these annotations up here, will just get appended if you have the metrics enabled on Ratify. So. And then from a user experience point of view, there aren't many changes. It's really a few flags extra in the HTTP server. So you can specify like the metrics type. Right now, we're gonna only support Prometheus, so it's defaulted to Prometheus, and then you can specify the metrics port that you want the metrics endpoint exposed on. And that's basically it. I've defaulted metrics to always be on because they can just flow to the metrics endpoint, and it's up to the user if they want to set up Prometheus and start scraping those metrics. That's what my reasoning was. If others think otherwise, let me know the reason not to.
I had a comment in the doc, a couple of comments in the doc. If you run Ratify as a CLI, does this become a prereq? Does it light this up, or does it kind of like, is it config based? My expectation is that you explicitly say that enable telemetry. And even if the config gets a little bloated, it's better to be explicit about, yes, we want the telemetry to be on, otherwise. And maybe you ship with that as a required section, right? Like of the configuration. But it's clear that it's kind of something that we turn on or turn off, depending on where you're running it. As a CLI, you definitely don't maybe need an HTTP server running with telemetry emitting, right? The other thing that I wanted to ask was, are we, these dimensions are created dynamically, right, by Ratify, like depending on what they are. So per verifier, do we emit these? Like this is the E2E for a specific verifier. And is there a concept of a correlation ID where one request from gatekeeper can be correlated across through multiple requests inside the verifier?
Yeah, that's a good point. There is no concept of that right now because gatekeeper doesn't expose that. As far as I know, we don't have correlation ID that they expose in the.
No, but when we emit a metric, could we emit it in such a way that there is an E2E metric that, as well as, I mean, we know the request time, right? Plus we know per verifier metric as well. They're probably different metrics, right? Okay, I understand that there's no correlation possible, but do we emit, I'm guessing from the graphs that you had, there is a P95 verification request latency. That I'm understanding is the end-to-end, right?
That's the end-to-end, yes, yeah.
Do we have a notion of individual verifier metrics as well?
We do, yes. So there's an individual verifier duration metric as well that can, and then it has dimension by the verifier type. And
oh, sweet. Okay, so then I guess both my questions were answered. The P95 request verification latency includes the mutation, or is it separate?
So it's per handler. So just for the verification portion, just for the mutation portion. It's currently not combined between the two because from the Ratify server perspective, it doesn't currently correlate that for this sub in one deployment flow, this was called before, and then after I'm looking for the verification. So
is there something that we could use? Like there should be something from gatekeeper saying that it is a deployment or something, right? Or no?
So I can see if the underlying HTTP request has a correlation ID header, and the actual payload they send us, it does not have any of that, but maybe there is in the header of the request. So that's something to look into.
The reason is most of these investigations come and we find out that the second call doesn't come after the first one, or this gap of this invisible time, right, that we lose in between these requests is hard to trace. So having something end-to-end would help. I mean, on the contrary, maybe you say that gatekeeper is the one that needs to track this, and that might be okay. But as long as we have some story that kind of like covers this for end-to-end, look here, or this is the metric that we emit that is our end-to-end, that would help many of these investigations, right?
I think that's actually a really good point. Like, how would we're talking about metrics here, but if we wanted to, maybe this is where the tracing comes in, but if we wanted to investigate like what were the different durations for a single data point, if we don't have a way to correlate among them. I think that's what you're trying to get to, right?
No, that's fine. For metrics, obviously, we don't have correlation. But sometimes you have, if you've seen flame graphs, what they do is you look at the end-to-end and then you kind of like see spikes in them, and then probably, but the problem is that none of these spikes are long enough to explain why the end-to-end is slow. So you end up trying to kind of like narrow down that the caller might be the one that's kind of like introducing latency and things like that. So maybe as a part of your investigation, if you know that to find out the end-to-end, you have to go to Gatekeeper, that might be the answer, and that's okay. But if you can emit it from Ratify directly, then it becomes, okay, this is what the E2E for the specific call was, including mutation and the verifiers combined. Because we do have all the verifiers combined, but we don't have mutation together, right?
Yeah, so mutation is completely separate. So
The hope is they add up.
yes, exactly. Hope is they add up, and hope they're somewhat sequential in the way they're called. But again, these are all hopes.
Right.
I think we'd have to rely on Gatekeeper to provide some sort of correlation between the mutation call and the verification call, because you could potentially have different resources being created, which all refer to the same subject. So you can't rely on uniqueness there either. So, okay, I'll look into it, see if we
Yeah,
can.
I mean,
get something
definitely not a part of solving this, but I think overall, I feel pretty positive about it. So
Okay.
to see that it's actually making it way. Thank you.
Yep. So just circling back to the CLI versus Kubernetes scenario, making sure that the metrics are only emitted when you're in cluster or when you have the server up and running. So right now, the way I've implemented it is it's tied to the metric server is tied to the life of the Ratify server. So if you run the serve command, that's only when these flags will actually be used, because the flags are attached to that. So CLI is not going to do anything, but yeah.
But there's no way you're not explicitly requiring them to say that Prometheus has to be enabled, right?
Yes, that's missing. So we could say like turn on, like a flag to turn on.
Yeah, I mean, it's your call. I mean, in the end, I think I have liked to see when, let's say, for example, when we're running distribution, good to see this is where the Redis server is, this is where the Prometheus endpoints are in the config, and there's less guesswork, even for somebody who's kind of like just getting started.
Makes sense. Yeah, sure. I'll plan on adding that. I think that's a good thing to follow. So yeah, so that's kind of how the metrics will work for Ratify. I've added like a list of proposed metrics, and this is kind of where the discussion I think will be helpful. These are just ones that I thought would be helpful, but if others think there are other ones that would be even better, or maybe we should change what we have right now, we can.
If you can add to this list as you kind of started speaking, I thought about it. Do we have notion of when the cache gets resolved versus when you're actually having misses and whatnot?
So the tricky part of that is we have so many layers of caching. Like, do we emit metrics for each cache layer, or do we dimension it by the cache too? And what would be, is that actually, from someone who doesn't understand the implementation of Ratify, is that actually a helpful metric to have?
I see this as this is what would cause a 429 on a target. So for example, if your registry is a target, we want to know how many requests are going out to resolve. So if Horace is making a call, we know that.
Yeah.
But if it's serving from the cache, we also know that. So I think you need a way to kind of like at least tie each one of these, that your dependency is not being hit, so that you can either optimize the cache or not. I think the final goal is to be able to say that you're not caching enough, or we need to introduce caching here. So unless you have a miscount, it's going to be hard to kind of like see that. Now, if you can say that for each request, your number of verifications is equal to the number of resolves, then that's might be okay to determine what the cache request is, cache miscount is. So think about it, and maybe I don't know, we're using memory caches, we're not using any other kind of cache, right?
Apart from the OCI store, yes.
Is there anything that we need to report on the OCI store?
So one thing that would be helpful is to report the size of the OCI store, because if that grows too large, you could run into like out of memory issues for the pod.
Mm.
But we could also there's a way to do a cache hit too for that. Because we actually first checked to see if the OCI store already has the artifact cached in it. So it would be the same way as if we did our memory-based caches.
Yeah, think about it. I think this is additive, so it's not like a set in stone kind of set of metrics, right? I think the first cut is pretty good. Like each one of these requests will tell you whether, obviously it's not a hit, it's not a cache hit, so I can derive it out of that.
Yeah.
But if there's anything that you need inspection, like the memory footprint or the number of subjects that are already cached, right? Like then it's hard to guess, like once the system is running for a long time, how many subjects are already being cached, right? So that's kind of the other pivot of this, like just to kind of look at the health of the container would be hard if you don't have any insights into the cache sizes or the memory sizes.
That makes sense. Okay. Yeah. So I'll look into seeing if there's a good way of doing that. I think we could probably bundle that into one metric, but I'll see if that makes logical sense.
Yeah, you do have size of our cache folder. Do we really need or care about it? So that's kind of where I was going with this.
Yeah. That's actually
as a P2 if you want to, like move it down in the, I think getting the durations are kind of critical because we are running hot with the gatekeeper timeout, right?
Yeah, I think that's where we need the visibility. Yeah, so I think the other question, so sorry, go for it.
No, you started.
So the P90, so in the Grafana dashboard, we measure the P95 request duration, and that's just at the handler level. So when Gatekeeper calls the Ratify's external data handler, the mutation handler, this is the P95 for that. Same thing for the verification request latency. So those two you can grab from the first two metrics. So the verification request duration. The other part that's very, very critical is understanding like the number of actual requests the ORS client is making out to registry. So that can get us the actual status code from each request. So that's what we can leverage to get the 429 count. The other interesting thing that I wasn't sure if it's worth actually collecting is, do we want to break down the registry requests by the full request URI? And is it important enough to calculate or collect the duration of each individual request to the registry? Like, is there any value in that?
More than the individual request duration, that we can actually even look at the registry and sometimes derive out of it. But what would be challenging, and what we have seen with Kubernetes especially, is the file access and the extraction time of a given layer. So if you are going to pull something from the registry, getting it on disk, because you're bound to disk IOPS and things like that, it would be good to know after you initiated the pull, when were you able to kick off the verification? So it would, before you actually call verify on it. So you do an ORAS pull or something like that. So that is the pull duration or the unpack duration. Getting that as a metric would help you determine how much time are you spending within disk IO, as well as like maybe the request count together. And you can then drill into that, saying that, hey, you're actually spending a lot of time with disk IO. Bump up your disk or maybe give more IOPS to this pod might be one. It would be an easy way to kind of like diagnose it. So I think that's what I would spend more time on. When you get the verification duration, if it's high, you know that it's not the verification that's costly, but it's more like the amount of time spent in pulling plus extraction, if there is anything, or at least disk writes are going to be a challenge.
That makes sense. Actually, that makes implementation-wise that limits it to just the ORS level. We're not relying on a special custom round tripper logic in the actual ORS client. So okay, And
Because you have multiple requests, right? Like you
Yeah.
could argue that, hey, it's manifest fetch, or it might be layer fetch.
Yep.
But in the end, I think the primary motivation should be fetching content from the registry is slow, and then we can drill into and add additional instrumentation as needed. So second round is what I would say that is.
Okay. Yep. Makes sense. The next one was on, so Susan, this is where I wanted to get your opinions on the cert fetching logic.
Sorry, before we jump back,
Yes.
can you make sure that ORAS has correlation across one pool? If not, we should.
Okay. Yes.
So like when you access a target registry, you use the same request ID or request correlation ID, and you can see that for this specific pool, this is what happened. These are the requests that kind of came in, and we can correlate back.
Sure. So do you know if they implemented now, or should I can check? I can check. Sure.
Yeah. Okay. If not, you make an ask on them to fix it.
Sounds good. Okay. Actually, let me make a note of that. Actually, do that here. Okay. Moving forward, Susan. So on the key vault or any sort of cert fetching operations. So I was looking at the CSI secret store driver, and they measure like the time it took for them to actually fetch the key vault objects. We can do that as well. I just in our scenario, the fetching is done not within the verification flow, so timing wise, it's not as much of a concern. So I was wondering, is that actually, do you see that as a metric we want to track? Instead, do we want to track like the number of certificates that we've pulled, or?
Yeah, I think it's not time sensitive, so it's lower priority for sure. I think it's good to know the like the frequency and the duration and the certificate number. But I briefly spoke to Anish earlier, like about a couple of weeks ago, because we were concerned about the key vault, like 4,000 requests per 10 seconds or something. And I asked Anish, have they ever hit the limit on, because their code, if you have more than 4,000 objects defined in one CRD, their request will never succeed, because they'll have this giant array and it'll always fail. Like they don't do it in batches.
I see.
So those metrics will be helpful, like knowing the object length of the array would be helpful for if we were to make improvement. Like our key vault fetching logic today is also pretty simple. We just, if there's a change on the CRD, just go fetch them all. But ideally, like if we want to be smart, we can actually detect what's the diff, which certificate we have already fetched and cached, and only fetch the new ones. So having that metric will help us optimize, but not a high priority right now.
Okay. So I guess useful in determining the number of objects that we're querying, but it would probably be like a P1 or P2 level, maybe not in the initial set of metrics that we. So okay. Makes sense.
Yeah, and Anish said nobody ever requested more than 4,000. So
okay, that's good.
My understanding is you're setting up a framework to add more, and first cut will be P0 metrics, and then we can take it from there and add as needed, right?
Yes, yeah. So P0 metrics that I've kind of earmarked are the verification request duration, mutation request, and the count, and then the final one is the system error count. So really just 4 are the core ones that I've specified, and then after that we can build on it, and there'll be documentation to make it easy to do that. So and we've discussed this one. So yes, this is the verifier duration. This is at the individual verifier level. We can, some of the attributes I was thinking of dimensioning by are the verifier artifact type. And then if we have some sort of way to correlate between the actual requests and the individual verifier operations, then we would add that to be able to correlate them together. For the identity operations, One that I thought of was the initial AAD token exchange duration for Azure Workload Identity and the for Azure Workload Identity specifically. And I know Key Vault and ACR both use that, so we could add that as a dimension to see like which operations, if it's a Key Vault exchange or an ACR exchange.
Does Ratify have any process to kind of like refresh these tokens?
We do. So actually, for the Key Vault part, I'm not sure, Susan, if we have that, depending on the AAD access token expiry. I think it's 24 hours. At the Aura store level, we actually have a way to refresh the tokens.
But it's not on the hot path, right? Or is it?
It's not on the hot path.
Okay, cool. So then really, do you need to worry about the durations?
Yeah, that's actually fact. There's one scenario where it is on the hot path where for whatever reason the token has gone bad, and then it goes through that process within the verification operation. So we don't have an asynchronous refresh operation, and Jimmy was kind of pointing to this too, that maybe it would be worth for us to have like a process that will periodically check and make sure the tokens are all valid, and then do the updating there.
The CRD already does the refreshing, right?
So are you talking about the workload identity CRD that is also installed on
Our
cluster?
CRD to access Key Vault and refresh the tokens, refresh the certificates already has a worker that does this. Is that correct, or?
No, they only get reconciled on customer update.
Oh, okay.
Yeah.
So we don't automatically pull Key Vault for any kind of updates right now.
Correct. Yeah, we don't support rotation, and if we say like if you need to update the version, you can update the CRD, pin it to the updated version, which will trigger the reconcile loop, and will fetch the certificate. And fetching of the certificate, it's not a part of the verifier cycle.
Okay, so there's nothing that keeps any. Okay, I am anticipating a bunch of jobs here, which is going to be things like cache pruning, access token refresh, possibly even cert refresh. That might just happen on the side on a lower frequency. Let's cross that bridge when we have to. At least for now, let's focus on the metrics first, and then we'll come back to that. Let's not solve that along with this is what I think.
Sounds good. Also, this is along those same line for the ACR. What is the actual refresh token operation duration? Because we've noticed that takes a little bit longer. So might be helpful to pin that down. The other part, this metric, I wasn't sure how useful it would be, but actually understanding how many artifacts are attached per subject, because that kind of dictates how many verification operations are going. Well,
there's a number of verifications per request from Gatekeeper, right?
So the number of that would be at the HTTP server handler level, and that'd be per subject that is passed in. But at the each subject will have multiple artifacts, and it's not necessary that each artifact equals one verification, like verifier operation for Ratify. You could have multiple verifiers that are kicked off per artifact. So the previous metric, which is this verifier duration, the count of this metric would get us the number of times we verified, gone through a verification operation, but that could be equal to or greater to the number of artifacts that we've actually encountered per subject.
Maybe I'm not understanding, but looking at number of looking at the HTTP request to Ratify, looking at the total number of verifications across all verifiers
Mhm.
should tell us roughly how many artifacts have been looked at, right?
So it'll roughly tell us, but you have scenarios where you could have, let's say we lit up the multiple verifiers per artifact scenario, then you would have multiple verifier operations for that single artifact. So you could potentially have more.
No, but my understanding is that we have a metric per verification.
Yes, so that metric would be per verification, but is there any value in understanding how many artifacts itself are attached to the subject? Maybe not, because really what we want to track is the number of verification operations.
Right.
So
Because if you squint at it, you know you had a subject,
yeah,
and if you know you have configured 2 verifiers, you kind of know roughly. The point is, if you can derive anything out of it, the additional metric doesn't add too much value. But let's say, for example, you had an outlier metric you wanted to track in the sense of number of artifacts that you're pulling, right? But if we track with auras the latency for the pull, you get that as well. So I think you will have to follow through, right? So you'll have 1 plus, but that's still, from magnitude wise, it's going to be pretty much the same. Does it make sense?
Yeah, that makes sense. I think from metrics perspective, we're more concerned with trends and not with like specific individual. Yeah.
You have to sort of start tracing for that, right? That's.
Yeah. Okay, makes sense. So I think for now I'll remove that. And then this is like a very generic error bucket count. And this is where I wanted to get your guys' feedback on, first of all, like error count, I think in general could be helpful, but what counts as an error and at what level are we actually aggregating the errors? Because right now, a system error count from the highest level perspective for Ratify would be, oh, there was the handler itself failed for, like, if the handler timed out, that would be a system error. But in the verification operation, for example, if there's an error, let's say the verifier was not configured correctly, or for whatever reason, ORS failed to pull an artifact, like that's also an error. But how would that bubble up? Because currently we don't bubble that up as a system error. We bubble that up as in the verification report, we just denote, oh, there was an error here. And we let Gatekeeper handle parsing the error report to tell that there's an error.
So you have a metric on the top for number of verifiers, right?
Yes.
My understanding is that is actually verifier success duration. Do you have a verifier fail duration? Like not exception, but signature was wrong, certificate was incorrectly configured. The reason is I would consider that as an anomaly, like you have something messed up in your cluster, and that is, if the failure count spikes, then you know, not just error count, right? So that would probably emit both, like if the request has failed or if it's actually failing to even verify, which is actually is it a 200? I don't know whether it's a 200.
So we return a 200 in the Gatekeeper.
Distinguish that then.
Yeah. Okay, so that makes sense. So having like a delineation between like a verification success request.
Right.
Okay.
Yeah, I mean, total request is going to be everything, right? Like you have
Yeah.
total, and then you have success, failure, and you have error count. So like actually different buckets. So splitting that up will help you write some kind of alerting saying that, hey, if you have this many failures, somebody's trying to deploy something really bad, or your artifact configuration is messed up or something like that.
Makes sense. Okay.
Because we assume the happy path is the case, but most of the time you want to pay attention to when errors happen.
Yeah. And I think we've just been testing with our happy path, and
so along 200, you want to be able to say this was a failed request, and that way we can then determine whether it was a duration failure or something like that, or just incorrect. But then you kind of jump to logging. As soon as you see failure request, you look at log, and then you go there.
Makes sense. So yeah, these are just a list of metrics that I could think of. Anything else? Anyone
Looks
else? Okay. So yeah, so I'm gonna phase the implementation. So the first phase, I've already completed the PRs and review. Thanks, Susan, for starting to take a look at that. So that just adds all of the framework for the metrics, adds some documentation, and then adds these 4 initial metrics. Phase 2 was part of the work in order to light up the number of the status code per registry request in ORAS. So previously we were using the HashiCorp's retry client because ORAS Go didn't have the retry client support until recently. So by switching to the ORAS Go's native retry client, we can actually implement some custom logic in order to capture the request status code as well as the request URI if we want to grab that in the future. But for now, we'll stay away from that. And then phase 3 will just be implementing the rest of the kind of the top metrics we were discussing today. And then after that, we can open up issues as more metrics become relevant and asks come in. So yeah.
awesome. Do you mind prioritizing the success failure into the set?
Sure. So I'll add that in the phase 1 then. We'll include that. Okay.
Awesome.
And then the final part is, so this is kind of like an add-on that we've done. So support for dashboard, just a sample dashboard where they can see some of these metrics. I've the walkthrough that I've created also installs Grafana on the cluster, and then it exposes Grafana dashboard on a cluster-wide IP, and so you can access that, an external IP in the cluster, and you can access the Grafana dashboard. And then we've, based off of the basic dashboard we've created, you can see all of these live. But I put a note that this is just as an example. If you're going to use it in production, please follow the correct ways of properly exposing service endpoints for your metrics and figure out a way how you want to actually integrate that. But this is just the full end-to-end experience for metrics.
Very cool.
Yeah. So yeah, that's about it. One final thing was security in terms of metrics emission. So 2 parts to that. One is currently the metrics endpoint is a non-TLS based server. And my understanding based off of how other projects have implemented is that metrics are kind of like are fair game to be like a very low risk data. So it's a lot of them don't even bother with setting up a TLS based server. So that's why I haven't done that. But if we believe we need to have a higher bar for that, I can look into setting that up.
Do you know what the secret store CSI driver does?
They don't. They just expose as a regular HTTP. So
I would say maybe call precedence to that and then follow it this way.
Okay.
Because that is technically it's a security volume mount, right? So, and if they are okay opening metrics, it's in the same way you're mounting you're not even mounting secrets, you're mounting certificates, but that is literally going to validate stuff. And so we trust Prometheus not to have vulnerabilities and all that. And so there's a dependency on, if we have a dependency on Prometheus, if Prometheus has CVE, we have to expedite the thing going forward.
Okay, makes sense. And then the other concern was, how do we, I'm not very familiar with how it works with Kubernetes, but how do they scrub or detect if there have been leaks in metrics? Like, I know like for Azure stuff, we have our own way of doing things. Is that a concern where for example, the HTTP request URI, let's say we start emitting that and it has a token in there and accidentally we didn't account for that. Do we need to be concerned with
are you talking
an instrument that will detect that and then scrub the data, or?
Are you talking about, sorry.
PII?
Yeah, PII inside responses?
Yes.
Accidentally?
Yes.
SDL, unfortunately. I think that's the only thing I can say. Yeah, I mean, we're not doing tracing here, right?
No, we're not. So we don't have to worry about
Not yet.
as
Not
big an issue. Yeah. So
logs are fair game. Like I think once you get to the node and then, or you kind of like follow logs,
mhm.
you are expected to see some amount of PII in the logs. It depends on implementation to implementation. So I don't have a concern with metrics yet. The only thing that it could expose is the name of the verifier.
Yep.
I don't see any other information here besides numbers.
So if customers set this up on their cluster, we don't have access to their metric and the log. They will have to hand it to us to, if they choose to hand over to us.
No, we typically they'll surface a problem saying that this is what the request duration is. What do we do next? And then we kind of go down tracing at that point in time. At least that's what I'm thinking right now. So, but once we start getting metrics, we'll see more problems.
Yeah.
And we
Right
won't get
now
that
we're-
automatically. Like they
No.
will report problem and they would open that information if they choose to.
Yeah.
Right now we're blissfully ignorant. So
This is awesome. This is awesome. Thank you.
so I'll update the document with some more discussions, and then yeah, Susan, if I'll address some of your comments on the PR, and then if you could take another look, we can
Yeah,
at least.
I've taken some quick notes as well. Like I can merge that with your notes after this meeting.
Sounds good. Thanks.
All right. Anything else?
I think Susan, you had one.
Yeah, I had
that took
a
up all the
one
time.
quick item. Let's see. Makash, since you're sharing screen, can you click on the PR?
Yeah.
Yeah, the PR is still in draft mode because we're still clarifying which properties we should include in the status. So I've pasted like the latest screenshot. So Akash, if you scroll up a little bit, it's the output of a kubectl get. So if you see like, show me get or the certificate store that Ratify currently defines, like you'll see the first two items, it's cert store, AKV, and if you do a get, I've made the its success and error and the last fetch times like printable columns as requested by Xinghe. And the follow-up discussion is, should we include provider-specific properties in the status field? So today, our certificate provider get certificate returns the generic like X509 array of objects. So so we don't, like a key vault specific property would be the name of the certificate, the version of the certificate, and when the certificate was created. So all that information is currently being just logged. So the question is, should we have a very generic status? Like if you want to see the status of the CRD, I can tell you, okay, the certificate was fetched successfully, versus we can display all the provider specific properties that, we'll try.
Is my lack of understanding of Kubernetes itself? Is the expectation that you can take an output from describe, modify it, and then apply it again?
I don't think you can. It's not a full spec, right?
Yeah, I haven't tried that.
Okay.
The status is at the end. So the spec is what the customer specifies. So they, for example, they'll specify the name of the certificate, but they won't specify the version. So then we will go fetch the latest version. But Xinghe brings up a point that, okay, maybe when we see the status, we're also interested to know what version did we end up fetching.
Status is fine, but you have kubectl describe right on the top there. Is that common practice to actually take the output of describe, modify something and update it? Because part spec and things like that, people do that. is what I'm understanding, or maybe I'm totally wrong here.
I see. So if it is a common pattern, then it's worth having all the specific, because then people can look at the output of describe and then try to update the CRD. Is that
I'm totally asking here. I have no knowledge
okay? Yeah.
about this,
I don't know.
So
Well, I can talk to Singular.
maybe getting some experts input would help, like
Yeah.
whatever.
Sertac, I can.
Yeah, definitely.
Yeah. Okay. Thanks for the feedback. Yeah, it's been a very useful hour. I think there's
Yeah.
lots of good discussions.
Right. Thank you.
Thanks for joining, everyone.
Thank you. Bye.
See you
Thank
next week.
you.